Okay, we're gonna set up a fucking motion study for this thing here. Let's see what it is. Okay, so we're gonna add a pathmate motor, and select that. Has our path, and let's change the direction, and .50 inches per second. Click OK. Okay, I've already expanded it to 1 second just by clicking on the key and click edit key part-time. So, oops. Weird. Okay. Pretty groovy. No. Okay, let's see. Sure, gonna need those again, but edit feature. What the okay. Okay, we're going to select segments, for our function, and we got to enter, let's see, start x index 0.6. Value should be 15 inches is our displacement, and it will be a cubic spline that we're going to use. And I guess we've got, wow, lots of different profiles you can choose here. And I sort of don't like what they're doing with this, because they're sort of cheating. But 0.6 to 1 second, want to move 35.9 inches will be our, I guess, the absolute position. So you can kind of see in these graphs what it's going to do here. Okay, as you can see here now, this is the velocity with respect to time. It's going to speed up and then slow down to 0, then speed up and slow down to 0, at that point in time. And you can kind of see that reflected by this inflection here. And it kind of levels out, it's our displacement. displacement kind of slows down, but then acceleration graph, you can see it's accelerating and then decelerating, but very linearly, and then all of a sudden it jumps and starts accelerating again at a very high rate. So, which is unusual. This jerk thing, I don't really understand this much. Like I said, I can estimate that there'd be some kind of an impulse here, for that sudden change, but I don't know. Anyway, let's just calculate it and see what happens. It seems to accelerate properly, so I mean, I don't know. Again, I don't know what that jerk thing means. But it's acceleration. That's fine. I mean, whatever. Acceleration is usually a constant thing, and it's not unusual to see it linear like that, I suppose. So basically, we can. But, anyway, it does, I can see an acceleration, deceleration profile in there and everything. I mean, it looks reasonable. Okay, let's do plots. Displacement, velocity, acceleration. Subcategory, linear acceleration. Tangential component. Okay. Must be tangent to the path, and I'm supposed to select this linkage here. And click OK. Alright, if you want to get like your fucking axis to show up on your chart, because like I said, 0 was missing, that really annoys me. I mean, 0 crossing should always be on a graph. Anyway, I had to go into the scale thing and just deselect all these from automatic, so I could set it between major unit, minor unit, which minor unit could have been something other than 10, but in fact I might actually go try this 1200 and put the minor unit to like 100 in this case, and the major unit like, I don't know, 500. Well, no, I mean, it's got to be a multiple of, well, I mean, I guess it doesn't have to be a multiple, but I'll just set it to 200, fuck it. But at any rate, that's the way to get her 0 crossing point, to actually show up as 0. So, because you always want to know, particularly on an acceleration graph, when it crosses 0, it's a very important point. That tells you the difference between it, basically accelerating and decelerating. So, that point where it crosses the 0 line is always important. And I think these little herky-jerky points are when it's crossing these, because this is kind of a knitted together series of lines, so you can see that right there and right there, it's kind of crossing over into a segment, and same right there and right there. So here, of course, this is when we're changing, starting to go from 0 velocity to speeding up. So anyway, let me run this thing. Okay, that's just fucking great. Okay, so it's recorded my fucking motion in to it, which I really didn't want it to do, so I guess I'm kind of confused about that whole goddamn thing. I mean, I don't want it changing my view like that. But I guess I'm stuck with it doing that now, aren't I? Son of a bitch. Maybe I deleted the wrong key. At 1 second. I don't know what that key is. So, alright, well, anyway, I guess that's got us back to working properly. Okay. Alright, so we're going to actually superimpose another plot. Displacement, velocity, acceleration. Linear velocity. And radial component. And select that same object there. Okay. Okay, and then we're going to select add to existing plot and select our plot 1. So now we've got velocity, superimposed on our acceleration graph. So that's interesting. Okay, so I'm going to have to adapt this to let's see. Okay. Say approximately to what they chose here. And again, you can't just leave those alone. If you do, you still won't end up with your 0 on it. Because these things are in alignment, but they don't have to be because they're two different quantities. So it just gets a little confusing. I wish they actually were aligned, though. Anyway, I'm going to make this a multiple of that, so 80, and this minus 40. And that'll give us our 0, so our 0 is right here. Again, it'd be nice if these same 0 points were always aligned, but that's hard to do, and it would just be a visual thing if I did it. But at any rate, our velocities are in fact, I should just go and do this, instead of going plus or minus 800, let's just go 1200, and that'll make it uniform, and then I can go minus 80, and this will be uniform, so they won't be scaled differently. So at least they're proportionally scaled and centered, and that this way the axes are aligned. So, we start off at 0 velocity, and it gets down to a maximum minus 35 or so, and then, can get a reading on it. Let's see, that's inches per second squared, so that's our acceleration. And this thing won't. Oh, here we go. Shit. Okay. 12 inches per second is our velocity, so so I can get an exact reading off the graph, and you can see our velocity drops back to 0 right here, and then accelerates up to the peak over here, 73 inches per second, and that's, about the time our acceleration bottoms out. It starts changing to deceleration. Like I said, we got constant acceleration of this whole thing, period. It's you get the same graph, if an object were falling due to gravity, it's still constant acceleration, but velocity will change, and you can see it increasing, although that's an interesting inflection point. But again, it has to do where it's transitioning. So you can see these little points, and these are probably little errors in their interpolation method when they're trying to, again, stitch these, because they're going to have separate velocity curves or whatever calculated for each of these segments of this path. So I think that's where some of these errors are coming from. At least that's my theory anyway. Okay, well, they want me to change some parameters significantly, so I'm going to try to create new motion study, but I want to really duplicate this one. Okay, when creating a path mate or slot mate, okay, never mind. Okay, now let me zoom to fit this, and let's calculate it and see what happens. I don't know if it kept my plots and everything. So say I wish they'd show the magnitude of those vectors changing. Okay, yeah, I kept the plots. Okay. So anyway, in this we're going to do an angular. We're going to adjust the cycle angle. We're going to change the this, and we're going to click edit under motion. And under independent variable X, we're going to select cycle angle instead. So we're going to change it to 0 to 20 degrees and 360 from there. Okay. And click calculate. What the shit? Okay. Yeah, they said this was supposed to fail, so I mean, I guess it did what it was supposed to do. Okay. Okay, it said it failed because, it's only valid for one cycle of 360 degrees, because we just said it's 360 degrees. The problem is our our animation is much longer than that, than the time it would apparently take to do that. So it makes the thing fly apart. Okay, anyway, to fix that problem, I've got to go under Motion Manager Properties, and under Motion Analysis, click Cycle Settings. Or for cycle settings, I have to select cycle rate and enter 1 cycle per second, because it's simulating 10 cycles per second, and that's the problem. It's over 1 second. We're only defined 1 cycle, not 10 cycles. So disregard what I said earlier, although that might have been right. I can't remember what I said. Okay, now calculate it. Alright, that's 1 complete cycle, so now it works. Wonder what this damn thing is about. I might have to change my graph here a little bit, because I think the peaks are outside of the limits of it. Well, that's a big inflection. What happens at that point? Huh. Yeah, it's definitely a big hiccup in it. I know that's not going to be true in a physical system. So anyway. Now we're looking at an event-based motion system. Anyway, they got this sensor in here. It's like a laser sensor. It's a proximity type. So, as you can tell there, and other sensors we can use as well. So, and it's got an alert set to it for when it's true, so that means when it's being triggered. Alright. Like I said, that's the sensor, and then we got like 4 motors too in this study. And this linear motor 4 is just a constant motor at 75 meters a second. Interesting. Have to look at that later. And these are servo motors, and displacement type. And it says use event-based motion view to control the values of this motor, so that's interesting. In a regular motor, again, you get a lot of control over it, because this isn't a path motor, it's just a regular motor, but we can still specify segments or data points, expressions, etc. Or you can make it a servo motor type like those others. So like I said, a servo motor, you can do velocity or acceleration, but they're mostly event control. And you can also specify load bearing faces. I don't know what that's about, but anyway, these really, you don't have as many options with a servo motor. I mean, I don't think you can create a graph or anything. So, they're like a servo motor would be used for, to be controlled electronically, and that's what I think that's mostly used for, is for event-based motion, just like it says right here. So, okay, so here's the motion study that they, this is just by default, so I haven't done anything to it, but it's pretty fucked up, that they never tell you to actually run the motion study, and they want you to start modifying it, I guess. Okay, you can also look at the time view, and it'll kind of tell you what goes on, with these various components in the time view. So, and by setting it to the end of this key, I can tell you the motion takes about 2.25 seconds. Which honestly, the simulation runs too long because it doesn't do anything after that. If you can see what it does, then it does nothing. But these are triggers, these are actions, and these are the tasks that are performed. This task 2 is triggered by the completion of task 1, I assume. See what it says. Don't tell me nothing. It's suppressing a coincident feature here. And this is linear motor 4. It stops in task 1 after a tenth of a second. This tells you the times these things take. You can see right there it's 2.26 seconds again. We got a Gantt chart over here to, I don't know if you can edit anything in this, but no, it looks like just a display. Keep in mind, this doesn't have anything to do with this over here. This first task, set to basically stop the motor from moving when this event is triggered. Or when this proximity sensor is triggered. The duration of its, hundredth of a second, and set to linear, so it stops the motion linearly, and it lasts that long, hundredth of a second to stop it. Now this is a linear motor. I mean, it's actually a motor. That's not a servo. The other ones are servos, if you recall. Okay, let's see what happens. I duplicated this fucking thing a few fucking times. Let me recalculate it. I want to see what happens here. Okay, just like everything else in this goddamn program, this has bugs in it too. You hit recalculate, well, you lose your fucking motion of this event. Now the goddamn thing doesn't do anything. You look at the keys there versus the keys here. Like I said, it's missing something. I noticed this when I went into this and modified the motor value like they said to do, and of course, it's losing motion keys. Piece of shit. it would probably do the same thing. Since I never actually hit calculate over here, it'd probably do the same thing in this if I hit calculate. I'll bet you it would lose these keys since this is pre-compiled. Okay, basically I've created a duplicate of the same thing, and I'm going to try to recalculate. Okay, this is interesting. Okay, got that one up right. Interesting that this closes the motion study every time I flip back to it. Why does it do that? Remember that little gear study I had open before? It didn't do that. Let's see. Now let's go ahead and bring this one up. Look at its motion study. I'll go ahead and close this graph. Oh. Okay. So anyway, that motion study's up. Let's go back and look at our welding robot, whose motion study's closed. It's closed on this one too. And it's closed on this one too. I don't understand what's going on. Because last time I had two of these up, you know, it kept the motion study open for the drawing I was finished with. Now for some reason it's closing it. Didn't used to do that. Anyway, setting that aside, well, hold on. Okay. Anyway, but I'm gonna okay, the robot's doing its thing, right? Okay, and like I said, over here, again, we're missing keys. You know, it doesn't weld anymore. It just does that. So, but again, my theory is that's because I hit recalculate. I'll bet you we'll lose those weld keys when I recalculate it. What do you bet? Yep, just like I thought. It's a bug in the goddamn program. Like I said, there's no reason for it. You know, the task definitions hadn't changed at all. I mean, they're supposed to still work the same way. The one thing I did notice is this is moved. You know, from 0 to this 1.24 seconds. Again, based on the original. Now let me pull up our original one again, which is this one. Okay, look at our motion study. Okay, it's still got its keys, so that's good. It didn't alter this file. But then again, let me close this. Oh, shit. You know, save all is probably saving all the parts, even though there's no modifications that have happened to the parts. There's no reason for it to do that. Okay. Now to save this motion study, as fucked up as it is, and let me go ahead and close it. See? God damn it. Now let me open our first study again. Let's see if it's still intact. Yeah, we still got our keys, so that's good. At least it didn't alter my original file. That's one of the things I was afraid of, so I don't have to be paranoid about that. Okay. At any rate, as far as this thing losing keys, I don't know what the fuck is going on. Because like I said, I don't dare recalculate it. Guess it doesn't matter. Well, it does matter because I wanted to look at it as a reference. Well, I can. This is the best one to do it in. But yeah, I mean, like I said, after it gets ready to weld, well, that's it. You know, nothing more. Or is it supposed to start its welding process at that point? So again, this, just like every goddamn thing else in this program, is full of bugs. But, you know, you can tell when I hit calculate, you know, that something's fucked up. And see, it starts at 0 seconds. Okay, and then it goes through that hiccup. Doesn't do shit. But it's obviously, you saw those green things highlight. You know, again, about the time it's having that hiccup, and you'll notice these green highlights right there. Another goddamn flaw too is, you know, you can't use the scroll wheel with this graph. You know, I mean, if this was like, you know, had like 100 steps in it, boy, that would annoy the piss out of me, not being able to scroll through this at all. Fucking total idiots. Anyway, we know we have an error somewhere here. I mean, because like I said, it works up to that point. And again, you can't fucking scrub this or any goddamn thing. It's another idiotic thing they did. You know, the only thing you can do is try to use this stupid time bar, which sucks because you can't scrub it. But, you know, at this point, you know, we have no more, you know, no more motion. And the frustrating thing too, it's not even generating any errors or anything. There's no like error messages. You know, there should be, but there aren't. So who the shit knows? You know, what's really annoying is this is like Service Pack 4, and they still have bugs in it like this. You know, so it was like late 2014. You know, looking at what they got in their thing here with the magnifying glass, I mean, it looks identical to what I have here. So, definitely a bug in their program. And by Service Pack 4, I mean, I can't believe nobody's complained about it. So, I don't know. One thing you can tell is different, you know, is these times down here, which pretty much match what they have in their little diagram, but notice that they're missing from ours. So you can see where the trouble really begins right here. I mean, it just craps out when it hits that point. Okay, what's interesting is I think, tracked down the error a little bit, because, you know, I changed this from task 8 end to task 8 start, and now it works. You know, we can see we have our keys back, but of course it's going to work wrong. And there's our trigger, okay. Set that into place, and now it starts doing its thing. Here, let me back this out a little bit. But now it is performing its weld operation. It's just anyway. So anyway, I was going to say that, you know, with that being the case, you know, the bug could be centered around this, but this seems to work okay. So it doesn't seem to be a routine. Well, let me calculate it again, see if it acts weird. Okay, it still acts weird. So it has a little glitch, but it does complete the operation. But you know, so our bug is either in task 6 that it doesn't know that it's ended for some reason. So I don't know. Let me try to set it back to task end in that and recalculate it. But anyway, it's either some kind of flaw in this, but again, it seems to be okay if the task ends. Now, say it's jammed now, you know. That's what I'm saying. It's almost like it doesn't know that the task has ended. Anyway, I altered the motion study 2 where I slowed the motor down, you know, the first linear motor down. That's why it takes so much longer. But I also changed some of the motor profiles as per the tutor. So, you know, what you can see, instead of being just linear, you know, this one's set to harmonic and this one's set to constant acceleration. And you can see definitions in the tutor, you know, descriptions on what all those mean. So, you know, in this little section here, next to the last page of it. So, okay, so instead of that taking 15 minutes, I spent like, I don't know, 2 hours on it.